Hi guys, welcome to another Maths NBT revision video. I'm Nick and Sensor is taking a break today. He's asked me to help you guys go through some past trig questions. Now, before I begin, I'd just like to go through a comment that we received on our channel from Leto, who says, Sensor Nick, I wanted to thank you guys so much. I watched all your videos and I didn't struggle with my NBTs. In fact, almost 20 questions appeared as they were. I'm so grateful. He goes on to say that he'll tell his friends, and that's the little he can do. But I mean, that is a lot for us. Guys, if you can tell your friends, if you can subscribe, like, all that good stuff, and if you comment, then that really helps the channel get noticed by YouTube and gets recommended to other YouTube viewers. The other thing I want to know is there is an incentive to this. As you can see here, we're on 3.47 thousand subscribers. So 3,500. We want to get that number up to 5,000. So as an incentive, when we get to 5,000, we are going to release our matric revision program. So that is, aside from the NBTs, that is our program that's going to help you guys if you're writing your matric maths. We will be helping you with that, and English as well to come. So yeah, if you guys help us, then we will continue to keep releasing new content. And yeah, we're getting a lot of guys saying that they're writing their NBTs and these questions that are coming up exactly as they are in the exam. So this is all good revision for you guys to do. So let's get to it. Let's do some questions. All right, so the first question says the isosceles right angle triangle shown is divided into strips of equal width. What is the fraction of the triangle shaded? So the easiest way to do this is to just do it visually. Is to think of, just to break this up into little triangles, right? If you look at this triangle here, okay, and I look at that, and look at that. This small triangle, do you see that this square would be two small triangles, right? And so we could divide this into a number of sections of little triangles. And we can count those little triangles, and the shaded part, which is the white, will be the fraction. So it's important to bear in mind that each of these squares is two triangles, right? As we can see. So let's count them up. In this first column, we have one there, and then there's two in each, right? So it's 2, 4, 6. Well, there's 2 in there, 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 2 in there in each square. So we got 1, 2, 3, 4, 5, 6, 7 times 2 is 14, plus that 1 is 15. So there's 15 little triangles in this first strip. Then there would be 13 next, because we've got one triangle, and then 2, 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6 times 2 is 12, plus this one triangle is 13. We notice it's going to go down by 2 each time, because each time you go down, it's one less block. So we're going to see a pattern here of 13, 11, 9, 7, 5, 3, and 1. So we add those up, because that's how many triangles we've got. 15, 13 is 28, plus 11, 39, plus 9, 48, plus 7, 55, plus 5 is 60, plus these last 2 is 4, so that'll be 64. Okay, and in the shaded area, we just need to count the white ones, right? So that's 13, 9, 5, and 1. So 13 and 9 is 22, plus 5, 27, 28. So there's 28 out of 64. We simplify that. 28 can be divided by 4 to give you 7. 64 can be divided by 4 to give you 16. 7 over 16. The answer is D. All right. Let's go on to the next one. give the range of the following. Okay, so what I want to do here is just draw this, a regular sine graph, just to show you what happens. Yeah, okay, so this is a regular sine graph going from 1 to -1. Okay, and then this goes 180, and we know it's 360. Now, if we have a half here, this changes the domain because it means that your frequency is halved, which means that you get half the number of waves in 360. So technically this would become 360 and this would become 720 because there's only half a wave in 360. But they're asking for the range, not the domain. So we don't worry about this half. It doesn't actually factor in here. What we care about is the amplitude, because the range is the y values here, which is the amplitude, right? How high up does it go? Well, a regular range is between 1 and -1. But what is the -5? Well, the -5 takes it up to 5 and -5 because it is 5 times. Now, the minus, all that does is flips the sine graph from this way around to this way around. So it doesn't actually affect the, let's just draw that a bit better. It doesn't actually affect the range when I flip it. Okay, all it does is change the orientation. It's rotated about the x-axis. Okay, so we see our range. Is put simply, the normal range of -1 of 1 to -1 just becomes 5 to -5. You multiply the range by 5. Okay, but what happens here is everything gets taken up by, in pink, moves up by 8. So what does that essentially do? That essentially moves this up by 8. Right, so it goes from 5 up to, what's 5 plus 8? 13, right? And so if it's moved from -5 up by 8, it's going to go to, I haven't really drawn this too well. It would have moved up a bit higher, right? So to -13. But it goes from -5 up by 8 to +3. So the answer is it goes from 3 to 13. Okay, so might have been trickier to do it visually, to explain, but I wanted to do it visually, but also just algebraically. What did we do there? The -5 changes the normal range by 5, meaning that we went from 5 to -5. And then by 8 means you just add 8 to both. Okay, so one more time. Its normal range is 1 to -1. You multiply it by 5 in red. It goes from 5 to -5. And then the 8 there just adds 8 to both. So 13 to 3. So if you didn't understand visual, hopefully you can understand those 2 steps that we did to change the range to B, right? 3 to 13. Okay, let's look at the next one. Okay, we've got to simplify 4 minus sine squared 6x. Okay, so let's do something before. Let's write this out and let's take out a 4. And so if we take out a 4, we get 1 minus 2 sine squared 6x. Okay, well, we know that cos 2x is equal to 1 minus 2 sine squared x. That's from our formula sheet. We don't get given this, so we have to just remember it. So cos 2x is 1 minus 2 sine squared x. So what happened there? We've got 2 sine squared 6x. So cos 2x would be 1 minus 2 sine 6x. So what do we have to do? We have to change this to cos 2x, right? So the 6x, well, what happens when we go from x to 2x? What's happening there? It's doubling, right? So this has to double to cos 12x, doesn't it? Okay, so we're looking at D. Just double check that. Okay, so we could work backwards, right? Because we know that cos, let's do that in purple. So this is the formula here, right? This is our double angle formula, right? Cos 2x is equal to, so if we had cos 12x, that would equal 1 minus 2 sine squared, and we divide the 12x by 2, giving us 6x. So we can see that there's our 2 sine squared 6x, so that must go to 4 cos 12x. Okay, so we're looking at D. All right, next one. Okay. Given the value of sine alpha x cos alpha and cos alpha y sine alpha, what is the value of cos squared a? Okay, so we want to be ending up with only causes. So notice that we've got this sine and cos a. So we must always remember when we're looking at it to try and we need to get rid of, notice that in the answers, so when we look at the answers, we've got no causes in there. So we need to somehow try and get numbers. Well, if you've got angles where you don't know the actual angle, you can't get a number unless we get this, right? If we get sine squared x or sine squared alpha plus cos squared alpha, that's going to give us a number, which is 1. So let's try and do that. Well, if I square both of these, I get sine squared alpha equals, and then obviously this then becomes x squared cos squared alpha. And then the cos squared, that becomes in cos squared x, so sorry, alpha, equals, and then we square the other side, and we get y squared sine squared alpha. Okay, so all I've done is I've squared both of these in order to get sine squared x plus cos squared, sorry, sine squared alpha plus cos squared alpha. I keep saying x, but remember that we've actually got x's here and y's here. So we don't really want to be calling it x. We want to call this the angle alpha. All right, so what does that mean? This one, sine squared alpha, plus this one equals 1, which means that these two in yellow must equal 1, right? Because those are equal to each other. So if green plus green equals 1, then yellow plus yellow must equal 1, right? So x squared cos squared alpha plus y squared sine squared alpha equals 1. Okay. Now we can look at this and go, okay, what do we need? We need cos squared alpha. Well, we've got our cos squared alpha. That's great. The issue is this sine squared. But what do we know? We know that from this, from green, sine squared alpha plus cos squared alpha is equals 1, which means that sine squared alpha, this one here, I'm going to do this in pink. This thing, when we rearrange this formula, we know that sine squared alpha equals 1 minus cos squared alpha. So we turn this sine squared alpha into a 1 minus cos squared alpha. Okay, so we've got equals 1 plus, okay, and then we've got the y squared still timesing in there. And then here we have, just bring this x squared cos squared alpha. Okay, now let's times this out. So we've got, I'm going to now do it in white because I think we're almost there. So x squared cos squared alpha plus y squared minus y squared. When we times this in, right? So what I'm doing is I'm timesing that and then timesing that, minus y squared cos squared alpha equals 1. Okay, I need to isolate because I want, well, I've isolated in purple. Yeah, this purple, I want this, right? So I want that. Okay. So, oh, it looks like I've done 2 of these y squareds, haven't I? I've done this one twice. Because it's x squared, and then this one here, this y, that's just a plus y squared there, that when I did that one there. Sorry. So now what I can do is I can take out the cos squared alpha. And I'm going to take this y squared across, right? So I'm going to take out the cos squared alpha, and I'm left with this pink one and this one here, right? So these 2 pink ones, x squared minus y squared. And what I'm going to do, this y squared that's on its own, I'm going to pop to the other side, and I get 1 minus y squared. Okay, and then to get cos squared alpha, I just divide both sides by x squared minus y squared, right? And then the x squared minus y squared cancel. So I should hopefully have this in one of my options, and I do. So the answer is C. Okay, let's go on to the next one. Number 5. Okay. Another tricky one. Thanks, Enzo. Okay, so here they tell us this: 3 sine x plus 5 cos x equals 5. And they're asking, what is this value here? Okay, so we know that 3 sine x plus 5 cos x equals 5. But then this one in yellow, this 5 sine x. Oh, there's a mistake here. This has to be a minus. There's a mistake in this question, because it's not going to work each of the times. This is going to have to be a minus for this to work. Okay, so then we're going to get a minus, because I can see there's a reason why the 5s and 3s are common, and you'll see why. So then 3 cos x. And this, what is the value? Well, the value is going to be, let's call it any random letter, right? So we'll call it k. So that's going to be k. Okay, now, because this is a 3 and this is a 5 and this is a 5 and this is a 3, what we can do is we can actually square both of these. So I'm going to square the one in white. And so the one in white here is going to be 9. So imagine if I was to times this out, right? So 3 sine x plus 5 cos x, 3 sine x plus 5 cos x. Okay, so that's what happens when you square it. 3 sine x times 3 sine x is 9 sine squared x. Then the last term will be 5 cos x times 5 cos x, which is 5 cos squared x. I'm going to do the last term here. No, 25. 5 times 5 is 25. 25 cos squared x. Now, the middle term is going to be 3 sine x times 5 cos x, which is 15 sine x cos x. And then the other one, the other middle term here, 5 times 3 is also 15 sine x cos x. So that becomes 30 sine x cos x. So we can say plus 30 sine x cos x plus. And what do we happen when we square the 5? 5 squared is 25. Now the k, the one in yellow. Okay, I'm not going to do this one on the side because if you can understand this one, you should understand when you square this one, 5 times 5 will give you 25 sine squared x. And when you square the minus 3 cos x, when you square that, you get plus 9 cos squared x. Now, what's interesting, this is why I said the 3, 5, 5, 3 is interesting and important, because when you do 5 times 3 minus 3, you get minus 15, right? So you would end up with a minus 15 there, and then this other one would be a minus 15. So you end up with a minus 30 sine x cos x. Well, that's beautiful because, and that's going to equal, now when we square the k, we get k squared. So what happens here is when I add these two equations together, right? So like, let's say I say, say 2a plus b, and then I have a plus 2b. When I add these up, 2a plus a, I get 3a, b plus b, I get 3b, right? So that's what I'm doing here. So I'm saying 9 plus 25 sine squared x is going to be 34. So I'm adding this whole line here. So 9 plus 25 is 34. The sine squares are like terms, so I can say that. Now, when I add 30 and minus 30, you see these go away, because plus 30 minus 30 is 0. So this whole thing goes away, this middle. And then the 25 plus 9 gives us 34 cos squared x. And when I add 25 to k squared, I get 25 plus k squared. Well, look at this. If I take out a 34, I get sine squared x plus cos squared x as our, take those out. Well, that sine squared x plus cos squared x, we remember from the original question, is 1. So we get 34 equals 25 plus k squared. Well, for this to be true, 34 minus 25 is 9. So 9 equals k squared. So k must be 3, because 3 times 3 would give you 9. But also minus 3 works, right? Minus 3 times minus 3 is also 9. So it's a plus or minus 3. If they had given you 3 as an option and minus 3 and plus and minus 3 is, sometimes they do that. Just remember, you need both answers, right? Because negative 3 times negative 3 will also give you 9. So the answer there is A. Okay, let's go on to the next one. 6, we're halfway there. And finally, we get a nice, easy one. What is the reference angle for 223 degrees shown here? Well, the reference angle is always the acute angle, right? So it's that angle there. Well, this is a straight line, so that's 180. So 223 minus 80, 180 is going to give you 43. So that's answer there is B, 43 degrees. Okay. Gee. Okay. For this one, when we have to prove our various identities, left-hand side to right-hand side, one of the tricks is to turn your bottom into a single trig function. So you don't want the term. So you don't want the 1 minus. And we see that in the answers, right? You have a sine A option, a cos A option, no denominator. And then here we have 1 minus sine A, which is completely different to 1 minus cos A. So The trick for this is when we want to turn it into a single term, we multiply by, if it's 1 minus cos A, we times both the top and the bottom by 1 plus cos A. And we're going to see why that is important, because if it was a plus, we would times it by a minus. And that's because when you times 1, you get 1. But when you times 1 by cos A, you get plus cos A. But then when you do minus cos A times 1, you get minus cos A, and the cos A's go away. And then you end up with the cos A times cos A gives you minus cos squared A. And so the bottom ends up being 1 minus cos squared theta alpha, which we know is equal to sine squared alpha, right? Sine squared A. So 1 minus cos squared A is sine squared A. So the bottom is sine squared A. So I'm just going to do the bottom there. So we saw how I did the bottom to get sine squared A. And then the top, 1 times sine A is sine A. And sine A times cos A is sine A cos A. Now we have to remember that we have 2 sine A's. Hang on. No. Yes. I just realized I can actually just, I've made it much harder than I needed to. I'm gonna carry on. I take the sine A out as a common factor, and I get 1 minus cos A over sine squared A. And then the sine A cancels with this A, and I get 1 minus cos A over sine A, which is, so the correct answer is A. Okay, but I didn't need to, once I did this, I could have actually just written this. You see, I didn't even need to times it out. I could have just written this as sine A and not even times it out, just multiplied by 1 plus cos A. And then I did the sine A's cancel anyway, and I get the 1 minus cos A over, 1 plus cos A over sine A. Okay, so at this point here where I turned this into sine squared A, I could have just canceled straight away. Anyway, really, that made sense. It can't always be perfect. All right. Let's have a look. A regular pentagon is drawn inside a circle with all vertices on the circumference. Find an expression for the radius of the circle if the pentagon has a perimeter of 50 centimeters. Okay, so with this, I'm just going to actually draw it. Okay, so let's draw a circle, and it's got a pentagon inside. Okay, so a pentagon, a regular pentagon, we know has all of the angles are the same. So I'm going to draw my pentagon. Okay, now a few tricks about this. So remember that a triangle has 180 degrees, right? Internal angles. A square has 360. What's happening each time? You're adding 180. Right, so remember a pentagon, 360 plus 180 is 540. And because it's regular, that would mean that each of these angles would be 540 divided by 5, which would be 108. So each of these is 108. Okay, so if it had been a hexagon, we add another 180 to this, we get 720, and we divide those interior angles by 6. That would be how we would do that. Let's see. So you'd get 120 if it was a hexagon. Anyway, we're dealing with a pentagon. So this is 108, 108, 108. They say the perimeter is 50, which means that each of these is 10. Okay, let me do that in a different color. So if that's 50, the pentagon, this is 10, 10, 10, 10, 10. Okay, so now they want the radius of the circle. Okay, so let's do the radius in yellow. So the radius would kind of be all of these here. Right? The radiuses would kind of meet in the center. Okay, so we want to get this and this. So let's just redraw this again. Okay, now, first of all, so we've got 5 angles here, and they're all going to be the same. And this is a circle, so that must be 360. So what's 360 divided by 5? 72. So each of these is going to be 72, the interior. So each of these here is going to be 72. Okay. Now these here, these ones on either side, so let me do this in red. So these ones here, those are going to be 108 divided by 2, right? Which would be 54. And of course, if we add those up, 54 plus 54 plus 50 plus 72 should give us 180, and it does. Okay, so basically we actually have everything we need to do it. So what I'm going to do now, just to make it a little more easy to follow, is I'm going to redraw this triangle like this. Now we know that these ones in yellow are both the diameter, the radius, and we know that this here is 10. And we know we've got a 72 here. And these are both 54 and 54 down here. 54, 54. Okay, well, notice we've got an angle and an opposite side. So we can use sine rule, right? Because we know that sine, I'm going to do it the other way around. I'm going to do 10. That's a 10 over sine 72 is equal to the one that we want, right? We want these yellow ones. So let's just call this x. X over sine 54. Sine 54. Okay, so I've done it in colors just so that you can see. So now I'm just going to do it in white now. So the sine 54 goes to the top of the other side, right? So we get 10 sine 54 over sine 72 equals x. Now, it would be really wonderful if one of those options was here, but it's not. So we have to do some tricks. So sine 54 is 54 divided by is 27. And 30, this is 36. So 72. And we're actually looking for 36. I think we want to work with 72. Sine 54, 90 minus 54 is 36. What's half of 72? 36. So this is what we're going to have to do. We're going to have to call this 10 cos 36 over sine 72 equals x. Now, the reason we're doing that is because the 36 and 72 we can deal with. Because what do we know? We know that the double angle rule, right? Cos 2x is equal to 2 sine x sorry, I could turn this into, yeah. So cos 2x is equal to your 1 minus 2 sine squared. That's not going to work because you don't want a squared x here, because we're going to end up with a 1. But what we do know is we know that sine 2x is equal to 2 sine x cos x. Okay, so this bottom, sine 72, right, would equal 2 sine 36 cos 36. So we can pop that over there. So 10 cos 36 over 2 sine 36 cos 36. Ooh, I'm sorry, sine 36 cos 36. And notice the cos 36 is cancel. And we're left with 10 over 2 sine 36. So 10 and the 2 cancel. So we get 5 over sine 36, which is B. That had a lot of moving parts. Wow. A lot of moving parts to figure that one out. So guys, we already know that the questions are the same. Some of these questions. So hopefully you get this and it doesn't take you as long to, we had to figure out the pentagon shape, the angles. There was a lot to do, but if you can just try and remember the solution, how we went to it, and the quickest way to do it would be to remember the answer. But if not, failing that, hopefully you're going to go through the other questions quick, which will mean you have a little bit of time to do these monster questions, which do come up. Okay. Okay, question 9, another tricky one. Okay, in figure AOB, AOB is the in the figure AOB is the diameter, right? So this is the diameter here of the semicircle, and O is the center. Okay, and the point X is the midpoint. Okay, so that's important, the midpoint. Okay, so if that's the midpoint, that is equal to that. But of course, you also know that this AO is equal to OB, right? So you've got, if this was 2x, right, then this one here, so you see that's there, and if I was to do a midpoint there, that would be there and there. So we could divide this up into 4 different parts here, right? So so that is equal to that, and then that and that if I had another midpoint. Basically, let's just divide this into that could be x, this could be x, and then this would be then 2x here. Okay, the other thing we know is that this here is the radius of the circle. So these two, this thing in yellow here is the radius. So then this one here would also be 2x over here. Okay. All right, so let's just write down what they've asked us for. So tan APX. Tan APX. So APX. So we're looking for this angle here. Tan of APX. So tripping on acid, right? Tan equals opposite over hypotenuse, right? So it's opposite would be 3x, right? Because it's AX. Right. Actually, let me just, AX. Then opposite over, and then this one here, opposite over adjacent. So the adjacent is PX. Okay, so px we need to figure out. So px, I'm going to figure out in pink on the side, right? So do you see that this is a right angle triangle? So we can use Pythagoras, right? So px is equal to the big side squared, 2x squared. So px squared is equal to the big side squared, that 2x squared, the hypotenuse, minus 2x squared, minus the little side, right? Minus the x squared. Okay, and so px squared is equal to 2x squared, 4x squared, right? The yellow is 4x squared minus x squared will give you 3x squared, right? So 3x squared. So px is equal to root 3 over x. Sorry, root 3x, right? When we square root both of these. So that'll be root 3x. Okay, over tan PAX. So now we dealing with, I'm going to do this in green. We're dealing with this as the angle, right? So tan PAX. So what is the tan is opposite over adjacent. So again, the opposite would be root 3x. We've already worked out that px is root 3x. Over, so green, the adjacent is this ax, right? Or ax we know is 3x. Okay, so you get 3x, root 3x, and so this, we could basically, let's write it out like this. 3x over root 3x divided by root 3x over 3x, which when we flip tip and times, we get 3x over root 3x times 3x over root 3x. Okay, and what happens? The x is all cancelled. We want that, right? Because we need a number. 3 times 3 is 9. Root 3 times 3 is 3. And 9 over 3 is 3. Okay, we don't have 3 as an option, but we have root 9, which is the square root of 9 is 3. So it's C. Okay. Guys, comment if you think I'm getting the harder ones in Senzo. I feel like these are all tricky. I'm just go and watch some of the video. Maybe they're all quite tricky, but I tell you, these NBTs, it's good to do this revision. I think it's, if you've never seen these questions before, it's quite tricky. Okay, I'm going to make this a bit smaller. So we get question 10. All right. So we've got mx equals sine x and kx equal. Okay, so let's use a highlighter here. So we've got sine x, mx equals sine x. So that's there. So that's the green one. And kx is the red one here, is equal to cos x. So basically, what are they saying? They're saying we put px. So they want the graph of px. So they want the graph of sine x cos x, right? Let's write that out. Sine x times cos x. Okay, so I'm going to do, this is an important rule. We're using it again. This sine 2x is equal to 2 sine x cos x. Okay. So this seems to be coming up a lot. So if sine, what do we can then change this to, right? Sine x cos x. If I divide both these by 2, so if I divide that by 2, the 2 goes away. and I get a half, because when I divide this sine 2x by 2, I get a half sine 2x. This here is one that you get given in your matric exams. They give you this rule. This one is a derived rule, and it's basically all I'm doing is I'm dividing both sides by a half. So just try and remember that sine x cos x is a half sine 2x, because then I can turn this into a half sine 2x. Now, what does that mean? Well, what's our normal amplitude for a sine x graph? It's 1 and minus 1. So if this is the amplitude, then our amplitude is halved to half of 1, which is a half, and minus a half. So I can rule out this one, which is doubled. I can rule out this as 1, and then I'm stuck with these two, where I can see that they've done the amplitude as a half. Well, what does our sine graph do? Our sine graph just starts at 0, right? So it's D. This would be a half cos 2x, this one over here. So that's not correct, because you see it starts at half, whereas your sine graph always starts like that, doesn't it? So it's D. Okay, there's our 10 questions done. Thanks very much for watching. I'm sure you're going to be seeing Senzo next. Yeah, all the best for your MBTs. I noticed a lot of you guys are watching your videos on Friday because the MBT is on a Saturday. But if you are watching on a Monday and getting an early start, well done. For those of you who are watching on a Friday, just try and get through as many of these videos as you can. Because as we saw from several of the comments, guys are getting the exact same questions coming up. One of them said that literally all of the 20 questions were the same as what she saw. So she obviously watched all the videos, and by watching all of the videos, you increase your chances of doing well in your MBTs. And the other thing, most of you have probably stopped watching now, watching the next video, but if you are still watching, just remember that if we get to 5,000 likes, we're going to be uploading that matric revision course, which is going to help you when you write your end of year matric maths. And as I say, the next milestone, we're going to be uploading English as well. So thanks very much for watching. Appreciate all the good comments. Yeah, I will see you guys soon.